Does anyone have scissors I can borrow? Oh, I
There you
found
go,
mine.
Michael.
Thank you. Let me reach that in there and get them. Okay, I got them. Somehow they
All
changed the
right.
color.
Michael, do you have a beer you can share with me?
Well, it is a bit early in the morning, but
Hey, yeah, but it's later here in Indiana.
that's true.
Whereabouts in Indiana?
North Central Goshen, about 30 miles east of South Bend.
Okay, my in-laws are from Terre Haute.
Oh, okay. That's over near on the west side,
Yeah,
over near Purdue.
yeah. My father-in-law was a boiler maker.
Ah, yes. And where are you located, Con?
We're in Seattle.
Okay.
Caitlin and I will be participating socially distant, me in my house and she in hers.
Yep. Good morning.
Morning. I was muted.
Good morning, everybody. I think we have a fairly limited group today, which will be nice. I think there's probably about 15 of us. We might be waiting for just one or two more folks, so let's just give it one or two more minutes here.
Right. I need a bigger desk for video conferencing. There's so much stuff.
Well, I think we have probably close to everybody. I want to start by saying thanks. Thanks for signing up for the Moodle Moot. Thanks for joining us for the circuits presentation. I hope you got your little bag in the mail of goodies that we're going to use today. I want to talk about Con and Caitlin. I was at NCCE in March in Seattle, right as this thing was hitting Seattle. This was early March, and the conference was kind of a hit or miss. I think it was, if it was going to go on or not. But I ended up in Cardboard Circuits and was thoroughly impressed with both Con and Caitlin, and asked them to join us here. And so glad that they could take the time to do this. And this is your first remote session that you guys have done?
Yes, it is.
Yep. So bear with us, please.
Yeah, we've done remote presentations of one kind or another before, but this is our first remote hands-on thingy. So it's
I'll let you guys go ahead and introduce yourselves and tell them who you are, I guess.
all right. Well, my name's Con McQuinn. I've been in science and technology education for a little over 40 years. I started my career at the Pacific Science Center Science Museum in Seattle, and I worked there for 15 years. And along the way got a teaching credential and went to work for what's out here is called an educational service district. They're called ESCs or BOCES or other things in other states, and continued to work in science education, educational technology, and even for the last decade or so got involved in neuroscience and learning. And it all kind of ties together. And Caitlin?
Con is my dad, so I grew up with all of that. I, lived in science education as a kid, and then went to school at the University of Washington and worked for 8 years in Apple retail and various types of their tech support that they have internally there. Volunteered in a lot of my dad's programs, so taught teachers both with him and at Apple. Teachers were our #1 customer in our internal support program. Took a little foray into self-publishing, and then went back to get my master's in education of learning, education technology and learning. So now graduated with that just in time for a global pandemic. And moving on.
So Caitlin and I have been, she's literally my earliest memory of her assisting me in an event was when she was 8 years old. So we've been working together on stuff for a long time. And at the Science Center, that was all about hands-on learning. Then I spent 25 years involved in formal education, but still kept coming back to the importance of hands-on learning, and in sort of a mild pushback again, well, not mild pushback, in sort of a pushback against the standards emphasis. One of the things that neuroscience has been able to tell us is that the role of, you can make it a spectrum, but play to any kind of self-directed learning is critically important. That if we spend all of our time directing our kids and telling them exactly what they need to be learning, and don't leave them any time to be choosing what to work on or exploring on their own, they're not developing the parts of their brain that enable them to be self-directed learners. And so a lot of what the context that we're going to be talking about today springs from that. Caitlin and I have run 3 summers of teacher maker camps now for NCCE, and that's really the core concept of the maker movement. If you are familiar with it, is that the students have to have the opportunity to self-direct. They have to have the ability to choose what they're working on, and that's what's critically important. And so that's going to be a big part of what we're going to do this morning, is letting you guys pick what to do, especially with such a small group. We can be incredibly informal, and we really want this to be driven as much as possible by what it is you guys want to take away from it. So I'm going to go ahead and get started with the slides. So our workshop goal is to introduce you to affordable and flexible resources and techniques for integrating simple circuits into STEAM projects. And we use STEAM instead of STEM, and the A stands for arts, because it's really the arts is part of everything that we do. And so we want to make sure that a lot of this stuff can be integrated into things beyond just simple science, technology, engineering, and math. So here is our schedule. We're going to do our introductions and overview. I had to really quick brain jump there, because wait a minute, it's not 8:30, it is 8:30 in Montana, it's 7:40 here. So anyway, so we're going to talk about why Caitlin and I took on cardboard circuits, why this is something we wanted to explore. Then we're going to talk about simple circuits, what we call cardboard tiles, and we'll explain more about that in a little bit. We'll take a 15-minute break at 10 o'clock, Dan. I think that was something we wanted to let people do. And then we'll talk about cardboard circuits beyond the tiles, give you some time to work on those. And then we'll talk about resources, tips and tricks, and questions, and maybe if we're lucky, answers. And that having been said, this schedule will probably turn out to be completely fictional. With only a half dozen people here working together, I think we can the schedule will be pretty flexible. We really want to emphasize having as much time for you guys just to mess around with the stuff as possible, especially with such a small group. This is a great opportunity to explore things and let you guys try things out and answer questions or ask questions. So what prompted us to move in this direction? In the maker world and in science education world, there's been a lot going on, a lot of cool stuff going on with circuitry. Most of you are probably familiar with the little doodads called little bits. They're really, really cool little electronic components that snap together with magnets, so you can build some pretty sophisticated circuits. The good news about them is they're accessible to kids. They're color coded. For instance, the green ones are outputs, the pink ones are inputs, and so on. The bad news with them is they're really expensive. Each one of those little doodads there costs between $10 and $20. So a relatively small kit of those can be very expensive. So while your kids can explore with them, when they're done, for one thing, it costs a lot of money to buy a whole classroom set. And when they're done building a circuit, they have to take it all back apart again and put everything back into the box. So it does not allow kids to create something that they can keep. Sort of an outgrowth of that over in the upper right-hand corner is, these are called circuit tiles, and we'll share a link to the person who originally designed these. They're using blocks of wood, and they take just the basic components and attach them to blocks of wood. So it kind of recreates what the little bits do, but they're a do-it-yourself sort of version, and they're a lot less expensive because you're buying the components yourselves. The disadvantage, again, is you have to take them back. The kids can mock up a circuit, they can explore a circuit, but then they take it back apart when they're done. They don't have a finished product that they can keep. And then a lot of you probably messed around with paper circuits. And paper circuits are really cool. You use copper tape and inexpensive things like LEDs and button batteries, and you can make these cool little circuits that you can keep. And that's one of the reasons they've been really, really popular. The downside of them is they're paper and they're floppy and they're not terribly robust. They're a nice thing the kids can keep, but they have to treat them very gingerly or they fall apart. Actually, they almost always fall apart just simply because it's made out of paper. So what we wanted was something with inexpensive materials and components, had an easy point of entry, a high ceiling of complexity. So you could start really simple, but you could get really complex with them if you wanted to. It could be adaptable to a variety of settings, to figure out some streamlining tips and tricks, and to have fun. So we have explored these to some degree with our maker teachers in our maker camp. Caitlin spent some time at the Pacific Science Center working in their maker space as a maker in residence. Plus, we did the workshop with Dan and company at NCCE. So be really upfront, we're still exploring this. We've had some chances to try them out with actual real live kids. Dan has had a chance to use them in his classroom after going to, or with kids after going to our workshop. Caitlin and I are explorers, and we're excited about what we're finding, and we're excited about sharing it with you. So the other thing I want to make sure that you're real upfront about is we don't believe there's any such thing as a dumb question, especially when you're dealing with techie stuff. And secondly, we love interruptions. If you have something that you want to ask about, please feel free to turn on your mic. I'll try to watch the chat window, but please feel free to interrupt us at any point in time. We're a pretty small, informal group, so that's going to work out fine. So this is the one slide that never wants to advance for some reason. There we go. So, Caitlin, you want to take it from here?
Yeah. So this is the first circuit we're going to make in a few minutes. But before we get into that, we wanted to talk a little bit about concepts here. Everybody comes to these workshops with different pre-existing knowledge about circuits, and we're not going to make any assumptions, and it's okay if you are going back to school a little bit on this. We all actually did. We've done a lot of learning on this. And one thing we like to disclose up front is just that electricity is a lot more complicated than we pretend that it is when we introduce the concepts to kids. So when the things that we're talking about today are going to be overly simplified, if you start to get into the weeds on learning about electricity on your own later, you're going to look back at this and think, boy, that wasn't quite right, because it's a very difficult concept to teach in simple means. But that's why it's been kind of boiled down to the way we're going to talk about it today. So what we're looking at here is we've got our battery pack, which you should have in front of you, and try to resist for a second grabbing everything out of your bags. We'll get to that really quickly, but I want to talk about a couple things first before we get distracted with stuff. In this circuit here, what's important to pay attention to, you've got your power source, and then you've got your positives and you've got your negatives. So you have the red wire coming out of that battery pack is a positive lead, and the black wire coming out of that battery pack is a negative lead. And to complete that circuit, we've got a component in the middle, which is our LED light, because that's what we're going to power with our battery pack. And that LED light is actually contingent on also being connected correctly from the positive side and the negative side. Now the colors of those clippy wires, you'll see those don't matter. Those are the alligator clips, and I'll show you those when we switch over to the camera in a second. But what you might be able to see here is that on this LED light, one of the legs is longer than the other. And on any component, not just an LED light, that is an indicator that there is a positive side and a negative side, because not all components actually have that, and we'll get into that later. On the LED lights, it does matter. If you put it on backwards, it simply won't turn on, and that's one of the most common errors when somebody is working on trying to set up a LED circuit and it doesn't turn on. More often than not, it's just because they have the circuit backwards. So, Dad, if you'll advance to the next slide, please. On the next slide, you'll see this, once you have this connected correctly, once you have positive cable, the positive lead from the battery pack going into the positive lead on the LED, and then closing the circuit into the negative, back into the battery pack, you will have a complete circuit. And when we're talking about circuits, closed means on and open means off, and that can be a little counterintuitive for some people. You also want to make sure that you don't create a short when you get to this point. It's actually pretty easy with the alligator clips to accidentally touch them in the middle of that LED, and I'll show you that too. And one heads up is first of all, if you create that short, your light isn't going to light up, because electricity is going to take the path of least resistance. It's just going to go from clip to clip and not go through the LED at all. But those clips are also going to get quite hot if you create a short. Not enough to give you a serious burn, but maybe uncomfortable burn if you were to grab them after they'd been sitting shorted for a little while. So just keep an eye on that. All right, now would be the time if you want to grab your goodie bag and pull out your battery pack and your AA's and 2 clippies, and grab an LED light that's green or blue, preferably if you have one of those.
Should I turn off screen share so you can start, Kate?
Yes, please. We're going to switch over.
Okay.
All right, you should all be seeing my desktop now. And I unfreeze this. Okay. All right. So this is what you should have in front of you. Battery pack, 2 AA batteries, 2 alligator clippies, and a green or blue LED. So first thing is you need to pop your batteries into your battery pack. So like this. Springy side, the negative side. The nice thing about these battery packs is they have an on-off switch, which can be really handy when you're working on circuits, but you just want to keep an eye on that. So when it's up like this, that means it's off. And when it's closed like that, that means it's on. So we're going to leave it open for the moment. So here, red wire is positive, black wire is negative. So that would be a closed circuit, but that would be a short because we don't have any components in it. For simplicity's sake, I actually happen to have a red alligator clip and a black alligator clip, which makes it a little easier to see what we're talking about in terms of positive and negative, but it doesn't matter what color your alligator clip wires are if you don't happen to have a red and a black in your pack. You see here, we squeeze at the large point here, the clip will open. It's a little strong. This is probably one of the harder things for little hands is just the strength of opening these, but if you actually work them a little bit, they get a little easier to open. One of the tricks, sometimes they can be tricky to get good contact. If you look real close here in between the teeth, you can see where the teeth actually touch really well in between a specific spot. That can be a good thing to look for if you're having a hard time getting it to clip onto a wire. One of the other, when we talk about most common troubleshooting things to look for when a circuit isn't working, you want to look for points where the contact is bad or points where you have a short. And oftentimes having a bad clip on a wire can be a reason that you don't have good connection. So what I'm going to do here now is I'm going to take my little alligator clippy and I'm going to clip it to this wire like that. And then I'm going to take my black one and I'm going to clip it to the black one. And so now these alligator clips are basically just extensions of these wires. Now I've got my LED and you can stretch yours out a little bit. I wouldn't overly stretch it because we're going to do some things with it later, and there's limitations to how many times you can stretch and unstretch and stretch and unstretch these components before these legs are going to snap. So we want to be gentle with them so that you don't lose a component when I'm not sitting right next to you and I can't just hand you an extra LED. So long side is the positive side. So we're going to clip that one to the red side. Short side is the negative side. So I'm going to click that to the black one, flip our switch on, and there we have a circuit. You guys should all have your components in front of you. If we were in a face-to-face workshop right now, I would walk around and look over your shoulder to make sure everybody is getting their circuit complete. Since I can't do that, please, lift your LED up in front of the camera if you've got it working, or unmute yourself and raise your hand if it's not working. Let us know if you have any, if you're getting it successfully done or not, so we know when it's a good time to move on to our next circuit.
Excellent. I see green lights everywhere.
Great. I can only see a couple of you, so if you can keep an eye on that for me, that's helpful.
So Jess also pointed out that, you know, when if we've gotten the legs bent out, that there's a flat, if you look really closely at the little collar at the base of the LED, there's a flat side.
Yeah.
I'm not sure you can see it on the camera because it is pretty tiny, but the flat side is the negative side. So if you've bent your legs out this way, so it's hard to tell which one's the short leg and which one's the long leg, you can look at that little collar. Although sometimes when you get the really cheap LEDs, it's hard to see. And we always get really cheap LEDs.
Yeah. We do love our cheap bulk components. It's blindingly bright. All right, we're gonna just give everybody a second to play with that. Why don't we go ahead and we can go ahead and switch to the next slide. I think people are fiddling with their LED circuit. Oh, I need to stop. I'm not used to the toggle back and forth. All right, I stopped sharing. If you would like to switch back to presenting. Okay, so the next component that we're going to play with is a DC motor. This comes with a little, that white plastic bit is probably not attached on yours. That's just a stand that helps hold it. You could grab that too if you would like. And you might see that I put a little piece of tape on mine so that I can see a little easier how it's spinning, because without the tape, you can't really tell what it's actually doing very well when we're playing with it. There's also some fun stuff you can do with that, which I'll show you in a minute. Before we bust that out, what I wanted to introduce here is that a DC motor is an example of a component that, oh, we were going to play with the buzzer circuit. We'll do that before we jump to the DC motor. I've already lost track of our order. When the DC motor is an example of a component that is conditional, it doesn't matter, well, it does matter, but it will work whether it's positive on one side or positive on the other side. What it just changes is which direction the motor will spin. I forgot though, before we switch to playing with the motor, we're gonna hop back. If you guys want to, let's switch back. Will you let me switch back, Dad, please? Got my notes in front of me.
While you're doing that, I'm going to answer a couple of quick, actually, no, go ahead. You got it?
What?
I said, are you ready to go?
Yeah.
Okay,
But
great.
there was questions?
There are some questions, but we'll talk about those after.
Okay. We're gonna back up just a second because I missed a step here. Before we move on from this little circuit, you have this little guy in your bag that looks like this. And if you have any reason you can't be super noisy in your home right now, leave the sticker on it. Not to spoil it. This one is another component that has a positive lead and a negative lead, which is why we were gonna play with it before we moved on from the LED. So if you just replace your LED in the circuit with this, long leg on the positive side, short leg on the negative side. And I don't know if you can hear that. If I take off the sticker, you'll definitely be able to hear it. And let me just tell you, kids love anything that makes a lot of noise.
Even us adult kids.
That's why we put it in there.
Yes. Yes, unmute yourself and let us hear your buzzers so we know you got it working.
Jess says her dog is going nuts. Yeah, these are the same. These are the little buzzers that go into smoke detectors. So
That's why I recognize that pitch.
yeah, and you can buy them in bulk.
They make great hidden annoyers.
So I'm gonna just respond to a couple of the comments and questions real quick, Caitlin, while you're getting the next thing set up. So Floyd said, I presume these LEDs have a built-in resistor, and the answer is no. We are risking destroying our LEDs because we're just cruel. That's when we do the basic introduction. Normally, if you're using a button cell battery, that's a low enough. There's low enough current and voltage in a button cell battery that there's really very little risk of damaging an LED. The reason Caitlin had you choose a blue or a green LED while we're using this larger battery pack is that it is too much for like a yellow LED or red LED. They don't light up well and they will eventually burn out. So when we do this as a longer, more involved workshop, we'll be introducing resistors, but for just getting into it, it's not really necessary. And Mountain
I mean,
Vapor,
and these LEDs cost about a nickel when you buy them in high enough bulk, so you can afford to, if they get blown out, if that's the price of getting a nice, easy, simple introduction, it's an affordable sacrifice.
and somebody with the login Mountain Daver, I'm assuming his name is Dave, but I'm not sure, has commented that, you know, for middle school kids and upper kids, you know, the positive is called an anode and the negative is called the cathode. But we're starting to real basic here. So,
yeah.
But I love it that you guys are throwing these kinds of comments in. That's great. And Jess mentioned, and Jess is from Deer Lodge. We have a good friend who lives in Deer Lodge. If you use a 9-volt battery, you absolutely have to put a resistor into the circuit, or it'll blow out the LED.
Okay, are we ready to move on to motors?
Yeah, you want me to put up the slide?
Yes. Oh, we already looked at it, remember?
Okay.
I think we can jump into just looking at components,
Just,
but I'll revisit the concept. So if you want to grab your DC motor, and if you want to grab your little clippy stand, it does just make it a little easier to hang on to it. In a minute, we're gonna tape this to things, but for now, just slide her on in there. If you have a piece of tape handy and you want to tape a little flag to your motor here, that is very handy and I recommend it. What we're going to do with this is we're just going to clip to these little leads right here. This is where it is. We also wanted to talk a second about soldering and encourage you to get into soldering. It's much, much easier than you might think that it is. You can get setups that are affordable, that are ventilated, so you can do it inside. There's a lot of really great options for it. These little connections are made to be soldered to wires. I had a wire laying around here, but I've lost it. But you would attach a wire similar to what you've got on the battery pack here to this connection here, and then solder it, and then it would be stuck on there for good, basically, unless you wanted to unsolder it.
And when we did the workshop that Dan attended, I actually set up a little assembly line, and I took 40 motors and soldered wires to them. It took me 45 minutes maybe to get them all soldered together. And that way there were wires on there for the participants to work around with. We couldn't do that with this workshop, but as we get further into this, we'll have other points where we'll show you where soldering would be a really helpful addition to your skill set. And like Caitlin said, it's just not that hard once you learn how to get started.
Yeah. Okay, so I've got my battery pack. Switch is open just because if this starts spinning while I'm trying to clip it, it's going to be difficult. I'm going to clip my positive to one side and my negative to the other. And then turn it on.
You're updating about 1 frame per second, just so you can visualize what people are seeing.
Yep. Okay, thank you. I'm going to switch polarities now, and I'll go a little bit slower for frame rate. So it spins kind of in the same direction that the positive current is going, kind of an up and over. It's hard to see when it's going full speed that it's actually spinning in a different direction when you switch it, but you can take my word for it if you can't see. So I'm going to switch there, and then we're going to take this one and we're going to clip it to this. That clip there. And again, not. All right, I'll give you guys a second to play with that.
Hey, Caitlin, you're right about the soldering thing. The kids love it. If you get an opportunity to do that with them, I set up several different soldering stations in my classroom, and they just love it. It's kind of cool to watch them.
We get the same response when we teach it in our workshops, that the teachers just get so excited. There's something just terribly empowering about being able to take that, learn how to solder stuff together. It's kind of like you're learning how to do wizard stuff. So Michael has asked if we have a soldering station that we'd recommend. We always use the same ones, and we have a teacher in a local private school that has a whole classroom set that works with us. So I'd have to contact her and find out which set she's using, because I didn't have to buy it, I always borrow it. But if someone else in the group has a set that they're using that they recommend, that would be great.
My setup was pretty kind of budget, to say the least. I had various different types of soldering irons. I had a big piece of plywood that I put on the desk, and then yeah, I just had the solder available. I had some alligator clips that they would. I didn't have the the third hand tool. They just kind of taped the things onto the board, and then they were able to solder away. So it was pretty budget, but it worked, and they just had a lot of fun.
So a little doodad like this is a nicer third hand tool. It's got the magnifying glass on it, so you can, if you need to, and you can move these alligator clips around to hold your circuit pieces together. That not only acts as a third hand, it helps keep your fingers away from the hot end of the soldering iron while you're soldering things together.
Which is probably pretty important for kids.
Yeah, it is kind of like a hot glue gun. No matter how hard you work, eventually there's going to be a burn. Nobody's going to die from it, but it's just I burn myself. There's a little collar on mine that's a little like a heat shield. So when you're holding it, and I just absentmindedly reach down and rest my finger on the top of it every once in a while, and it's hot. You don't do that. So it's
Mm-hmm.
So Gary asked LED color and voltage. What do the colors mean? And the colors, the chemistry of how the LEDs create color means that there's different materials in each LED to create those different colors. And some different LEDs require different levels of voltage. So that's one of the things as you get into, like Caitlin said, that it's not, we oversimplify things at first. We don't talk too much about the different voltage necessary for LEDs because in most simple circuits, they all work the same. But if you start getting really into creating complex circuits, you do need to learn what the different voltages are because it affects what's going on in your bigger, more complicated circuit. Every one of the sets of resources that we'll share with you at the end is, bulk LEDs in different colors. And when you pop open the lid of the little container, it lists the different voltage requirements of every color of LED right inside the lid.
And that's where you get into using resistors, which if you're not familiar with a resistor, it's a component that's specifically to down step your electricity or voltage so that you start with, you can't step it up, but you start with, whatever you have. This is quite high for a lot of the components we're working with, and the resistor modulates it down to match your component.
Yeah, Dan was just holding up, I think he's got the same box that we recommended that's got there's. So
yep. Very familiar.
And Floyd, yeah, when you buy solder, it's important to get the lead-free solder. And secondly, if it's got a rosin core. Yeah, there we go. Now I can see.
Yeah.
So yeah, we're not going to get too deep in the weeds there, but yes, that is something to think about. When you're using a button battery, it really doesn't make much difference because of the current voltage that comes out of that. But when you use one of these 2 AA packs, there is enough voltage that you'll see a difference in how the LEDs behave.
Okay, so the next component that we're going to play with is this guy, if you want to find this in your bag. This is a vibrate motor, just like you have in your cell phone. And if you also could grab your scissors and this silver tape. We're gonna try a little trick with this. This is one of the options that we have in your bag for ribbon, and we can take a detour for a second. We can talk about this. Oh, excuse you, motor. This is conductive ribbon, and this is copper tape. And they each have their benefits and their weaknesses in terms of when we use them where. We're going to use a little bit of the conductive ribbon for this, and because we have a little hack with these little motors, because they come with the teeniest, tiniest little wires with a very, very small amount of pre-stripped length on here, which is quite difficult to clip the alligator clips to. You can do it, but it's hard. So what we like to do is take a little bit of this ribbon and tape it to the ends of the leads to give you a bigger surface to clip to. So what I would recommend, my biggest tip and trick when you're cutting a lot of these, is to peel first and then cut, because they're a little annoying to separate. And if you cut it all first and then you have to peel the backing off, you're gonna have to do it a dozen times instead of once. I'm gonna get this going. And then I'm just going to snip off a little bit of this. And with both the ribbon and the copper tape, it's conductive adhesive. Best scissor choice. I did not grab the best scissors for this today. There we go. And you can buy copper tape that doesn't have conductive adhesive. Try not to do that, because that does not work nearly as well. Take this and just tape it over the end of the wire. And the big thing here is just to give it a really good pinch around the exposed part of the wire to make sure that it's making really good contact. I'm going to use my fingernail here and kind of smush it down like this.
Yeah, you can get again, when we share our, you might have already seen the resource list in the Moodle itself, that copper tape that you buy from your local stained glass supply shop looks the same, but the back adhesive is not conductive. And when you buy it even from the electronic supply stores, you'll see that there's tape that is conductive on the back and tape that isn't conductive on the back, and so it makes a difference when you buy it.
There are some things you can do with the stuff that doesn't have conductive adhesive. It's just limited. So in this component, just like the DC motor, you can connect it one way or the other, and it will affect the direction of spin. It's small enough that that's a pretty negligible difference. Here and here. Got my connections here. Yeah. And now I have my little jumping bean.
It's funny, we can't see it move, but we can hear it.
Yeah. Well,
So
you can play with your own.
Yes. So we're going to give you guys a minute or two to play with your own little motor. And if you have a cat around, it's usually pretty good at getting their attention.
Yeah. Yeah, the vibrate motor is for the cat and the buzzer is for the dog.
And just to say really clearly what I can't recall we said before, we're doing the basic circuits first before we get into showing how the cardboard plays in, because our experience in doing this before is we just wanted to make sure everyone's kind of up to speed on just the basics of the circuitry before we then get into building things out of cardboard, because having that basic understanding is really helpful and necessary when you get around to doing the cardboard part. And while people are exploring, does anybody have any questions? Jess, I'm very impressed that you could use your fingernails to strip those wires. That's a level of dexterity that I'm having a hard time even imagining.
Yes, and there are wire strippers too. That's just, they don't all come in sizes small enough for these teeny tiny little wires.
You know, the wires are so tiny on these motors because, like Caitlin said, these are intended to go into a phone. So it's going into a teeny tiny little circuit board. And that's why creating the little pads with the conductive ribbon on the ends makes them a little easier to use. And yes, we got them because we thought they would be fun.
Yeah. Our general rule of thumb is if it moves or makes noise, it's a good option.
The other component we really haven't talked about, by the way, are those nice little short alligator clips. There's only one place we found where you can get those little short alligator clips, and that's Adafruit is the name of the company. Again, the link will be on the resources, but most alligator clips you get are like long things, and it makes little projects like this, you know, just a mess. There's spaghetti cables all over the place. These nice little short cables just make everything a lot easier to do in this kind of an activity.
Are we ready to move on? Okay, we're going to switch back to the presentation real quick. We've got one more slide to talk about the next component.
All right.
So this is called the leaf switch, and this is the circuit that we're going to make next. We're going to look at this slide just because there's some finer detail here that I wanted to talk about first. First of all, I love how clicky this one is. There's three leads and two ways that you can use this component. You can use it so that it's on by default and it turns off when you click it, or that it's off by default and it turns on when you click it. And to do that, you want to make sure you're looking at it with the leaf pointed to the right, the same way that it is in the picture in front of you. And when you have it that way, when the alligator clips on the outside, then it's default on, and when it's left and middle, it's default off. All right. We're now going to grab your third alligator clip, and we're going to recreate the circuit that you see on the image in front of you. If you want to start going ahead and doing that, you can, but we'll switch back over to my document camera so I can demonstrate it. Okay. Well, you can keep whichever component you want to be in this circuit. If you want to use the vibrate motor instead of the LED, you can do that. That's totally fine. I'm just going to interrupt this part of the circuit here. I'm going to unclip it. I'm going to take my extra alligator clip and attach here. And this is definitely a little tricky. It's a good precursor to one of the reasons we like cardboard, because this will be a lot easier once we move on to cardboard. I'm just going to do the outside and the outside because that's easier with the alligator clips than left and middle. So now I have my circuit, which is on by default. So when I hold down the leaf switch, it's going to turn off. And if I let go, it'll turn back on again. Now, if I switch to left and middle without shorting the circuit, it is off by default. And when I click it, it turns on. One of the things that I playing with this leaf switch is cardboard pinball is in my future. You can probably imagine, make a pretty good little bumper.
Yeah, that would be cool.
So if you want to take a minute and just kind of play around, and you can swap out the components, swap in LEDs,
Yeah.
swap in the noisemaker. I mean, think about with the noisemaker, you could make an alarm where something sits on the leaf switch and it's in off while it's down. When it's on, when they pick it up, the leaf switch pops up and the beeper goes off.
I think I'll go ahead and introduce the very last component so that we can just give you a little bit of free time to play with any and all components you want and any and all combinations. Our last component is a tilt switch. And this little guy has a little ball bearing in it. If you shake it, you'll hear it. And on this one, replace my leaf switch. Let's spread these out just a little. So when it's on its side or upside down, the circuit is open, so it's off. And if I tilt it up, it turns on. And that's achieved by that little ball bearing falling down. And when that falls down, it closes the circuit.
It can also operate as kind of like a vibration sensor. If you put an LED in instead of the motor, you'll see the LED flicker if you shake it, because the ball bearing just bounces a little bit up and down and opens that circuit. So Jess, she says, I've never seen one of these. What kinds of applications does it have? So for instance, the motion sensor, if you use it with something like an Arduino or a little circuit board, it will detect motion. Think about any kind of circuit you'd want to build where if something's inverted, it turns off, and it's inverted, it turns on. Actually, let's see. Now it's not working. Huh. Never mind. I have a little demonstration circuit here, and I must have.
Might have killed the battery.
I might have killed the battery, or no, it's got a bad connection. So here are the LEDs on. You probably can't see that because of the light. When I turn it over, the LED goes off. So that's one of those. The application is what you can think of.
And that's kind of the end goal with this, is that once you introduce these components to kids and what they do and what their individual function is, then you really want them to go on eventually and invent their own thing. So you may not have any idea what they're going to come up with to use that tilt switch for in their own little cardboard and electronic invention, but they might come up with something.
So this is explore time. This is the weird part in the video conference where Kate and I stop talking. And you guys mess around with stuff. And if you've got questions, pop in and ask, or pop it in the chat window. And if I had the Jeopardy music, I would play it in the background right now, but.
Yeah, and again, if this was an in-person workshop, we would be wandering around and seeing what you were doing and noticing if you were having trouble, which we're at a disadvantage and we can't notice if you're having trouble, so please speak up.
Oh, Jess, you should be, we need to tap into you. You've got great ideas. She says YouTube has awesome timers with music behind it. All the time in the classroom. That's all right. I think we can deal with the awkward silence for a few minutes.
Yeah.
So one of the things I just figured out is if you have the little vibrating motor with the LED in series. Make sure I'm doing it right. All in a line. The motor will run, but the bigger motor, there's too much resistance. It doesn't turn over if you have the LED in line, or at least the green LED.
Yeah, just out of curiosity, try the yellow LED and see if it'll work, because that's the one that
Has
draws the
lower.
lowest.
It might, yeah, if it's behind. The DC motor does take require the most power out of any of these components. So it's the one that when I'm playing around for a couple hours, it's the one that stops working first because I've drained my batteries. I've
Gotcha.
definitely.
Yeah, and I don't know how fresh these batteries really are. So
Yeah.
While you're playing, here's a little thing that I made at the Science Center. Really great way to draw kids over to my workbench is to make a noisemaker. So this is the DC motor just taped to a piece of cardboard, and I took a couple of strips of copper tape, and they're actually just taped down to the little clippy leads here. And then I took the stand and I taped it here instead. Clip here, clip here. And makes a very, very loud noisemaker.
Yeah, if you start getting into this area, just Mitch is getting a multimeter, and that's multimeters are electronic devices that measure voltage, they measure resistance, they measure just simply whether electricity is getting from point A to point B. They're really helpful for troubleshooting if your kids start to get into these things. The more pieces there are in your circuit, the more opportunities there are for something to be amiss, and they're fantastic for troubleshooting things like like she mentioned in her comment, whether there's power left in the batteries.
Mm-hmm.
Jess, you say it'd be cool to use with waves. You want to? I'm having a hard time picturing that.
So I was just thinking that, when you're studying sound waves and stuff like that, you can talk about amplitude and
Okay.
stuff like that. And so I was just thinking, like, if we used the not the multimeter, but like the alarm or something like that, and tried to figure out a way to make it so that they can amplify the sound, or even to mute the sound and stuff like that, using maybe paper or cups or something like that, like, the whole put your cell phone in a plastic cup to amplify it deal kind of thing. So it'd be kind of interesting to utilize this in a little bit different way, not using their devices that they are attached to.
Right.
Yeah.
Yeah, and I hate referring to Mountain Daver as by his screen name, but yes, that's one of the things that we do in the longer workshop is we give people what's called a potentiometer. Caitlin has a couple of them there that she'll be talking about, and it's a knob or a slider that you can use to change the amount of voltage. It's basically it's a variable resistor. It changes. So we'll talk a little bit about those just to kind of tell you about them. There's not one in your kit.
But they're not terribly expensive if you would like to invest in them.
Other questions or comments? I can only see half of the folks in the group. That's the odd thing about being in the screen sharing.
Yeah. We have one more before break, right? We're gonna do cardboard tiles.
Let's do cardboard tiles, yeah. So we've got a half an hour till break, so we can work on that, or we can take the break early.
How are people feeling? We are flexible.
Go for it.
Okay,
All right. Verbal feedback, yay.
thank you. Okay. If you want to grab a piece of cardboard, if you've already got some pre-cut, this one can be on the small side if you've got smaller ones or bigger ones. It doesn't really matter. Maybe not too big because you do only have so much tape to go through. And if you had a ginormous piece of cardboard, you'd have to use a lot more of your tape. If you need to cut one down, now is a good time to do so. I'm going to use one of the littler ones that I happen to have on hand. And we are going to make our first cardboard tile. We're going to do an LED light. And what we're going to use the copper tape. We're going to use a little bit of copper tape and a little bit of ribbon on these tiles so you can see both and some of the tips and tricks for that. One thing here, once I've stretched these out, it's going to be harder for me to remember which one is the positive and which one is the negative, because when they're spread out, it's much more difficult to see. So I'm just going to try to be mindful of that I've got my positive on the left, and when I put it down on the desk, I'm going to keep it on the left so I can remember. I'm just going to gently stretch these out like he's doing the splits. Like that. And set that down for the moment. Positive on the left. I'm going to get my copper tape and I'm going to peel before I cut to save my sanity. And I like to just stick it and then cut it so I know how much I need here. My dad likes to wrap around the side for a little extra connectivity. That never hurts. That's my refresh rate going. So about the same. You see like this?
Sorry, I was on mute. It's going fine now. It's actually better than it was earlier.
Oh, great.
And Floyd had a great suggestion that if you're worried about forgetting which side of your LED is positive or negative and have a hard time seeing that little flat side, that before you bend it out, you can just mark the leg with a black marker.
Yeah. I'm intending on writing that on my tile, but that's another option. So now what's really important is when you do the other side, there has to be a gap. That is a mistake I've seen people make where they're thinking more about the LED than they are about the current, and they just run their tape the whole way across like this. That's going to create a short. So we want to make sure that there's a gap between the tape on one side and the tape on the other. Again. So I've got my copper tape. It doesn't need to be super pretty as long as there's a gap between one and the other. And I'm gonna go like this. So it's gonna span that gap. And then I'm gonna get another little bit of copper tape. And I'm just going to overlap this leg. And this is what we've found works really well for LEDs, is this under over technique, because it makes really good contact. And just use your fingernail there and kind of smush it so you're getting really good contact with that leg all around both sides. Give it a little bit of smush. This is one thing we found that sometimes with this conductive adhesive copper tape, that the conductivity of the adhesive can degrade a little bit if you make a circuit like this and you put it away and you pull it out months later and it doesn't work, even though nothing has changed. It's possible that's the reason why. We have yet to figure out if there is a variation in brand of tape, if one of them lasts longer than the other. But I have found that giving a really good squish on your LED seems to help. So that then you're relying less on the conductivity of the adhesive itself. And I was just going to, for my own memory, write just positive and negative on my little tile so I can keep track of which side is which. And now I'm going to bring back in my battery pack and my alligator clips. And clip on this side and on this side. And there's my circuit with a tile instead of just with the LED. So one of the advantages you might notice is that this is a lot easier to clip to than just the leads. It's going to be a lot more durable if you were to just leave it like this. It's less likely that the LED is going to get, that the legs are going to get snapped off or broken. And it's just a little bit easier for younger hands to work with too.
So this is the kind of thing that if you're working with younger kids, you can pre-make some of them for them, and you can see it's not terribly difficult. And if it's older kids, they can make them for themselves, or even older kids make them for the younger kids. So Floyd mentioned a difference between the copper and the silver tapes. So the copper tape is metal, and the silver tape is actually fabric. So some people prefer using the silver tape because it's more robust. You can bend it and flex it and it won't tear. The major advantage of the copper tape is if you decide that you want to do any soldering, like for this tile here, if you wanted to make it really robust, you go put a little drop of solder at the place where the leg goes under the tape, and then you'll have a really strong connection electronically that will stay, or electrical that will stay. You can't solder on the fabric ribbon. So if I Caitlin showed the little trick of putting the little squares on the ends of the tiny motor, that works great with the fabric, the silver fabric, because you can clip on it, clip on it, and clip on it. Because it's fabric, it'll be fine. If you did the same thing with a couple of little pieces of copper tape, every time you put the alligator clips on it, it crimps and it crimps and it starts to fall apart. We've
got another trick coming up that's definitely works better with the ribbon. So we have our purposes that we prefer one versus the other. We don't really side. We don't pick sides in this family.
The other advantage of the copper tape is the ribbon. If you want to kind of jump off into another direction, there's a ton of really fun stuff you can do with sewable circuits. They sell conductive thread. Especially the Adafruit website has a ton of resources on creating sewable circuits. And that ribbon, because it's fabric, you can actually sew things to it if you put that ribbon onto a piece of fabric or onto a piece of felt or something like that. And yes, yeah, the tape does, if you're clipping on and off and clipping on and off, the copper tape does start to, chew up. And if you've got the conductive adhesive on the back, you can just put another layer on top of it. All of this is awfully cheap. If you decide that you have to make a new tile, it's not expensive at all.
Yeah.
Floyd says, do we purchase most supplies from Adafruit? We purchase things like the alligator clips from Adafruit. Right now, I'm hopeful to find an alternative source, because I do have questions about Amazon and some of their practices, particularly issues about counterfeit things that people sell through Amazon. But the least expensive place we've found for buying these components in bulk has been through Amazon. So that's where most of our links are through. And yes, SparkFun has a lot of the same things that they have at Adafruit. So there's some, if you draw a Venn diagram, there's a big overlap in the center where you can get it from SparkFun or Adafruit. But Adafruit, when it comes to sewable electronics, Adafruit's kind of like the front and center. Plus, they've got some great educational resources on their website. And when it comes to blinky lights, Adafruit is the place to go for all the blinky light stuff. To get really technical.
I'm going to go ahead and make my next tile.
Yeah.
You guys can follow along if you want to. I'm going to make a tilt switch tile with the exact same technique as the LED tile. So I'm going to spread out my little tilt switch legs, and this is again a component where there is no positive or negative. It's just on or off. It's a switch. So got that.
Now, while Caitlin's doing this, bear in mind, we only, except for the LEDs, you only get one of everything. So if you can take these apart. If you decide to do another project later in the session and you want to reuse a piece, you'll have to pop it out and stick it into your new circuit.
And be gentle with those little leads, because when you bend and unbend and bend and unbend like a paper clip, eventually it's going to snap, which is not the end of the world when you have more than one of them, since they're so cheap.
Hey, Connie, Caitlin, with the thread, can you use like a wearable? Can you sew onto this?
Yes, you can sew onto the silver tape. Yes, so you can make wearables with that.
Sweet.
The tilt switch would be fun with a LED wearable. You jump around and it lights up like the light up shoes.
Yeah, in terms of, one of my favorite little home projects that I've done so far is my younger brother plays didgeridoo in a rock band. And he made his own didgeridoo out of PVC pipe and decorated it. And then I designed a circuit that can go inside the mouth of the didgeridoo. So as he plays music, the bell lights up in different colors. So that's why we have that A in STEAM, use the technology to do fun stuff.
Okay, now I've got 2 tiles. So I'm going to make a 2-tile circuit.
If folks don't have a third alligator clip, can they just push those 2 tiles together? Will that work?
Oh, it will, yeah. Do you only have 2 in your kit? You could also just tape the battery lead directly onto one of your tiles. So if you could do this.
Okay.
Plus, when we get into the next stage, you could just put the 2 components onto one piece of cardboard and just connect it. So you don't need the extra lead.
I'll show you though. I'm just gonna take a little extra piece of copper tape. I'm gonna overlap like this. Should be enough connection. Like that. That'll do the same thing. Now,
So one of the things that when Caitlin and I were working on putting this project together is that an awful lot of the simple circuit stuff that kids get exposed to, the only input in the circuit is an on-off switch. And then it's really all about different kinds of outputs, lights, motors, and so on. But there are lots of these kinds of, simple kinds of inputs, whether it's the tilt switch or the leaf switch And that's what we found makes the circuits really fun and engaging for the kids, is the more input options you can give them, the more creative ways to explore circuits they're motivated by. One of the things that we couldn't get into this kit, but we'll put it's in the resources so you can get them for yourself. They're a little bit more expensive. They're about $1 each. Oh, I haven't got one right here without me rustling through the bag, but it's a magnetic switch called a reed switch. And they cost about $1 if you buy them in bulk. And it goes on when you put a magnet on it. It goes off when you take it off. And there are lots of really fun things you can do with magnet switches. It just seems sort of like magic. You can put a magic wand over it and turn the circuit on and off.
I'll demo this potentiometer here. Just as another cool component to consider. And you can see, I can get both in the camera, that I can adjust the brightness by cranking the knob all the way up or all the way down. And this is also another means to talk about voltage and resistors, because you can actually see I can't turn it all the way off. It's still letting a little bit through even when it's cranked all the way down.
Oh, that's an interesting suggestion, Jess. I hadn't thought about that. She said she's seen some recommend you can take old phone charger cords that are broken, cut off the part that goes into the phone, and use the USB portion to create a low power energy source. That's, that would be, I'd have to take a look and see what the voltage is on those. I know the wattage is really low.
Yeah. It might be different depending on, it's probably different coming off the computer than off of a wall outlet.
So this is the point where we stop again and you guys make yourselves a couple of tiles and mess around. And we're going to give you 5 minutes to dink around. In the meantime, if you've got questions, either pop them in the chat window or unmute your microphone and ask us.
One thing before anybody gets the idea, I wouldn't recommend spreading the legs out on the buzzer. Just because they're so short that they're not going to, they may not necessarily get a good connection with the spread out trick. I'm going to show you a couple different options for it later. It's also, it just seems like they're a little bit more likely to snap on these legs than some of the other ones, a little less bendy than the other ones.
Yeah, and with the legs on the, whoops, I just went off the edge of my, there. With the legs on the leaf switch, there's kind of a trick with that Caitlin will show you.
Yeah.
When we get back together.
That's where we're going to talk about why we like ribbon too.
I forget, if you hook up LEDs backwards, incorrectly, I forget, do they just not light or do you burn them out?
They just don't light.
Okay.
The D in LED stands for diode.
Right.
And, yeah, and that just means they let electricity through one way and not the other.
Okay.
That's a good question though. Yeah, Caitlin talked about that if you make a short circuit, things heat up. One of the family stories from around here is I was driving one time and suddenly felt something very, very hot in my pocket, like disturbingly hot, like, oh my gosh, I have to pull the car over and stop and jump out. What's hot in my pocket? Kind of hot. And I had put a 9-volt battery in my pocket for some reason, who knows why. And the leads had gone across a quarter. and short it out, and it got really hot. Floyd says, what do you call it? Oh my gosh.
I saw the punchline. I didn't see the setup.
So what do you call a poem for the dead? A
Um,
diode.
Okay. That must be for your dead circuits.
Yes. I'm going to remember that one, Floyd.
Okay. Also, another thing is the thing that makes electronic circuits work is the smoke that's inside. Because if you connect it incorrectly and the smoke comes out, then it doesn't work anymore.
Yeah.
Yeah, I've done that. And it's really hard to put the smoke back in. It just doesn't work.
There used to be a professor at Montana State. His name was Fred Cady, and he used to talk about a lot about the magic smoke.
Yeah, as long as it's the smoke that gets out. When the fire gets out, then you're really in trouble.
You know, we laugh a little bit about the magic smoke, but if there's any little gizmo, like whether it's old TV reception or any device where you always had to hold it right or jiggle it, you start to get that magical thinking that, oh, I got to hold it right, when you're just completing and breaking the circuits all the time because of a loose wire or frayed wire or whatever. So we do develop that magical thinking about everyday objects all the time. Oh, I just got to hold it right.
Right. So Jess said, with the components with the short leads, can you just stick it into the cardboard with the copper tape, or will that make a good enough connection? And that's one of the things, actually, when Caitlin shows how we're going to use the ribbon with the leaf switch, that's exactly what we'll do with the ribbon. And with the leaf switch, you'll look at the leads in the bottom of the leaf switch, and they are like little blades. So there's more surface area to contact when you punch through. It does work sort of to stick the leads through the copper tape, but what happens is, as they start to move, the connection gets, less and less. So that, if you want to do the punch through into the copper tape, that's a really great place to do the soldering, because then you can fill that hole that the leg is punched through with a little bit of solder, and then you've got a great connection. So again, learn how to solder, get the stuff so that your kids can do it, because if you start to make bigger, more complicated circuits, it's a simple process and it'll make things just tremendously more robust.
In the short term, if you want to make something less permanent, the ribbon works significantly better for the punch through technique, which is going to be our next tile, spoiler alert.
So Jess says the buzzer plus the filter. It could be that the LED is using enough voltage that there's not enough to do both the LED and the buzzer. I have to go check the specs on the buzzer.
You could try the buzzer and a lower voltage LED and see if that worked.
Yeah, which if you're using the red or the blue, the green or the blue LED, they have less what's called pass-through voltage. So check the yellow LED, or one of the two clear ones is a fun LED, if you haven't tried it out yet, by the way. It's not just white.
Probably mess on parallel circuit too.
Floyd just put up a link that's one I've seen before, and it is a really good one, where people use brass brads from for holding papers together, and paper clips and cardboard. that's another great technique. Matter of fact, I'll go add that into the resources.
Are people ready to move on to the next tile? I can't see what you're working on.
I'm ready.
Okay, so we're going to talk about that punch through technique with the leaf switch. Also, we're going to talk about how to make this nifty, easy way to choose your direction on the leaf switch. This is one of those examples of this component being a lot easier to use on a cardboard tile than it is with just the alligator clips alone. So if I take this off here, I'll show you what we're going to create here. You can see it doesn't have to have very much gap, but there does have to be a gap between where each of these little legs punches through. We're going to recreate this here. So the first thing you want to do is just take your leaf switch and carefully but firmly punch it in until you have your 3 little holes, just so we know what we're aiming for. And we're going to start with the middle one first. You see how I cut a little chunk out? That's because this ribbon is too wide to easily span this hole. You're not going to be able to get it on that middle hole and not end up shorting one side or the other. So we'll start with that one, where you're going to take your ribbon and cut it down the middle, that, and then cut one of those little tabs off, like that. And now you have your little tab there that can fit in between those holes and not create a short. All right.
Yeah, peeling the tape is the most annoying part of the whole thing.
Yep, it definitely is. There we go. And the interesting thing, I may not hit the exact same holes again when I put this back in again, and that doesn't really matter, but it's just helpful to have a guide so you know what kind of spacing you need to have. The middle one, and then I'm just gonna go like this and overlap, make sure I overlap the hole, and then I leave a gap between my other piece. And the same on this side. Go. And now I'm just going to take my leaf switch, make sure I've got it lined up correctly so that each lead is in a ribbon and not on the cardboard. And you want it to be, well inside the ribbon. You don't want to get it right up on the edge. And punch it right back in. I didn't quite hit the exact same holes, which is actually probably better. It's probably stronger because it's in fresh holes. And that's in there pretty good. It's pretty solidly hanging in there. So now I've got my little component. When I go back to my alligator clips, and for our friend here that only has 2 alligator clips, you could probably overlap a little bit of copper tape onto the fabric, or underlap. You actually probably could underlap a wire on this, just like we did with the copper tape. I haven't actually tried that. So I'm going to make my circuit. And because I'm on the left and the right lead, on the outside leads, I'm on default on this component. If I want to switch to default off, just take this one and switch it to here. And now I'm on default off.
All right, and with that, we're at 10 o'clock. So I'm going to suggest that we take a quick break, 15 minutes. Anyone got any questions real quick before we do that? Astounding silence.
We'll take that as no questions is good.
That's the hard thing about this whole thing. Like, even during school, like, sometimes the kids have their video turned off, and that's, how that I think the most challenging part of distance learning is, how do you create that culture where you encourage, because turn your microphone off, or there's lots of different disturbances, especially with kids' homes and things like that, where sometimes it's a little more noisy than, so I think it's kind of hard. It's a different thing. So,
Oh, yeah.
Yeah.
I mean,
but this has been great so far. Thank you.
well, thank you.
I really like this.
Yeah.
Really like this,
there's something.
tape.
Oh, go ahead. I'm sorry.
Cool. Oh, I was just saying that I was just saying that I really like this threaded tape. I think there's lots of different applications I could use this with. I've never used it before, so it's pretty fun.
Yeah, it's really cool.
All right, Dan. So we just want to go ahead and do 15 minutes, and then let people. We'll return here. We'll call it at 10:15 Mountain Time.
Sounds good. Thank you, Con. Thank you, Caitlin.
That's great.
Well, since Dan is officially the host of the session, I thought I'd wait till he got back.
I think that's polite.
Yeah.
Okay, I'm back.
Perfect timing.
Okay.
So Kate, I'm going to show that little tile I was just talking to you about really quickly. Let me actually, I got that set up. Yes. So. Da-da-da-da-da.
That's a nice helper you got there, Caitlin.
Yeah,
I don't know if you saw how he came flying in and skidding across the desk. You wouldn't know that he's 14 years old.
So I did make a little circuit tile with the buzzer switch, and while Caitlin suggested, not bending the legs out, what I did is I did bend them out, and it's kind of hard to tell with the lighting here. It's so bright. Let's see.
I mean, bending them out once for this purpose, I'm sure is fine. It was bending and bending, that I didn't want to encourage.
So I'm going to take that off. So if you look really closely at the legs, I've soldered them to the copper tape. And then you can see little globs. I put a little hot glue on it to keep it, firmly seated. But now that I've done that, I've got a tile that I can use that is very robust and didn't work for some reason. So I've gotten something wrong with my batteries. I haven't been using this in the demonstration, so I didn't test it ahead of time.
Do you have it?
Oh, you know what? I had it
in the right direction.
I had it backwards.
Yeah, it does matter for this component. There we go.
There. I was just modeling how to make mistakes so you know how not to do them. So it is a nice thing that it actually has the little positive right there at the top, even when you take that little label off.
I've got another trick too for that particular component if you don't have solder handy. So we'll get to that.
Okay, so I'm going to stop screen sharing and let you take back over, Kate.
Okay. So my little trick for this guy involves spanning the edge. So this is a little bit different. It may not function quite the same as another tile, but it'll work. So we're gonna do, I think I'm gonna do ribbon for this one, but you could do this one with ribbon. I'm gonna take that back. I'm gonna use copper tape. I think the under over technique will work the best for this one to hold it in place. So what I'm gonna do is span a little bit of copper tape this way. And then a little bit of copper tape on the other side going the other way. So if this one's this way, then this one's gonna be this way. And I wanna make sure they're pretty close together on that side. Maybe even overlapping a little would be good. Because the plan, now that I've got it like this, is to take my buzzer and span it like this so that the leg is touching the copper tape on this side and this leg is touching the copper tape on this side. Right, now I'm gonna get a little bit more tape. Oh, I just totally smooshed my tape. And I'm just gonna overlap those legs to keep them in place. Make sure they're still in a good spot on both sides. And go somewhere else. It's probably the trickiest part to do with one set of hands. So you've got the one down, then it's easier. Switch that. This would probably also be helped by a little bit of tape just across the whole component to hold it to the piece of cardboard.
Yeah, one good tool to have while doing all this too is a hot glue gun or a low temp
Yeah.
hot glue gun. So you could put a little dab of hot glue on the bottom of it and then glue it to the edge of the cardboard.
There's my edge spanned buzzer. So I'm gonna get my flippies. And I think I'm remembering which side is positive and which side is negative. This one's gonna go here, and this one's gonna go here. And my, oops, and then I accidentally do that. It's okay, I think I can feed it right back in. Yeah, there we go. There we go. So that's your edge spanned trick. That's a little easier with like an LED because they're narrower. What the trickiest part with this was that it's too wide to just do it this way, that I had to twist it to get it to lay flat, which was a little tricky to hold and tape at the same time.
But Jess had asked about the punching legs through trick on
Yeah.
the, and with the legs are fairly short on the little speaker, and they're maybe not quite robust enough. We tried it out, and sometimes when you try to push it through the cardboard and the tape, the legs will buckle. But
Yeah,
what you
you
can
have to
do
be
is you,
really careful.
yeah, or you can if you take a push pin and use it to start the holes and then push it through, it'll work better.
Yeah.
And especially if you can then use a little dab of hot glue to keep it held down so it doesn't wiggle around.
Yeah.
And the best trick of all, of course, like I said, is then to put in a little bit of, get a little solder in there to
And if you're gonna do
tighten
the
up the
punch through, definitely encourage the ribbon, because the ribbon, the weave when you punch through actually helps keep a nice tight connection around the legs. Whereas when you punch through copper tape, it kind of, I think we mentioned this before, but when you punch through this, it kind of like squishes it around and then it stays, no, you can't see terribly well, but you can probably just imagine copper tape, it's not gonna tighten back up like a weave of a fabric is. It's gonna just squish out to make a hole and it's gonna stay that way. So then it gets very loose and wiggly connection with a little bit of wear.
Yeah, the trade-off with the ribbon is that you can't solder to it. You
Yeah.
can buy adhesive glue, and that's in our resources that you can dab onto the leads to try to improve the connection. That works as better if you then do that little dab of hot glue to keep the component from wiggling, because the adhesive glue will eventually start to crack and shatter if the component wiggles around too much.
Yeah. Does anybody have any questions? No? Okay.
Well, I'm just curious. I know some people use like Play-Doh circuits and things like that. Can you incorporate those right into the flow of this or not?
I don't see why not.
Yeah.
Okay.
Yeah. You could take your tiles, especially I think the ones with the copper tape that work better, you could put them between the blobs of the conductive cement or conductive Play-Doh. So, just kind of squish the Play-Doh onto the edges of the tile so they're really well pressed onto that copper tape. So instead of trying to figure out how to get an LED between two blobs of Play-Doh, you'd have a little piece of cardboard that you would put in between the two blobs of Play-Doh. I think that would actually make things easier.
Okay.
Oh, Jess asked, the tiles are all uniform. Did we purchase them? Is it worth it?
No.
And no, they're all uniform because Caitlin has by her right elbow a laser cutter. And so we put cardboard into her laser cutter, and that's why we can have such nice consistent.
Cheated is the answer.
Yeah, we cheated.
Yeah.
So find
Yeah,
somebody
it
from your
sure
city.
Sure is a handy thing to have.
Find somebody from your CTE department that has a laser cutter. And one of our tips, by the way, is if you need a nice consistent source of cardboard, number one, if you've got people that buy lots of stuff from Amazon, Amazon boxes are all one consistent type of cardboard, and that works really well if you're using something like a laser cutter. And the other is if you are just really stuck for finding cardboard and you actually have to break down and go buy something, U-Haul boxes are really inexpensive and really great quality cardboard. All of these things we have here are cut from U-Haul boxes. So
It is kind of nice to have consistency in terms of the width and the thickness and the durability of the cardboard when you're just to remove one more variable. But in general, we do fall on the side of better to repurpose cardboard than to buy it if at all possible.
Caitlin, which laser cutter do you have?
I have a Glowforge. I have the entry-level Glowforge. I'm quite a fan.
All right, thanks.
Been a while since I taught at a middle school. Would any of the die cut machines work for cutting cardboard?
you know, I'm not familiar enough with the die cut machines to give you an idea, but we've got some, just jumping ahead on our tips and tricks. For cutting cardboard, there are two tools that Caitlin and I are huge fans of. If you got,
Okay.
most people haven't got access to laser cutters. This is called a canary knife, and it's made specifically for cutting cardboard. It's Teflon coated. It has a very finely serrated edge. There's Caitlin showing it on her document camera, and it will saw through cardboard very, very quickly and easily. It's difficult, not impossible, but it's difficult to cut yourself severely with it. I can take it and run it on my fingers, and it's not a bit, but if you're moving really fast, we did have a teacher last year who got really overly enthusiastic and was sawing really fast, and she did cut herself with it. But it's a very, very child-friendly device.
Okay.
Yeah,
But
it's a bad paper cut is what it is. It's not stitches, but we do recommend just have your kid wear a glove on their left hand when they're working with their right hand. It's probably
Gotcha.
a good practice, because then if it slips and they get themselves, it's not going to get them.
So how old of a kid would you say could use that to cut cardboard?
Oh, I think with gloves, kindergartners could probably
Okay.
figure it out. It's
Yeah.
Cool.
it's very, very easy.
And it's nice for cutting, you know, curves and things like that. It works well for cutting out shapes. But yeah, you want kids getting in it's a good work habit to be using work gloves whenever you're using any kind of tool.
Mhm.
The other
They
one,
sell pretty simple, straightforward gloves at the Dollar Tree too.
so the other tool is this thing called a zip snip. And Katie, do you have yours there to put on the document camera? And it is a power tool. It's not one that, if kids were using work gloves, I would be comfortable with them using, but not barehanded. Again, it would be difficult to hurt yourself with it, but not impossible. But
Especially with little fingers, yeah.
Oh,
yeah,
yeah.
but it cuts through cardboard very, very quickly. When you have a big pieces of cardboard, like you want to take a cardboard box and break it down into little pieces.
It's a little noisy for you talking.
Yeah, go ahead and do it. I don't know if it really captures on little camera how quick and easy it is, but
Oh, yeah.
it is very, very, this is one of my favorite tools, period. Whether it's for cutting cardboard or those awful nasty plastic packages that you get that are terrible to open. These things, it just whips right through it like butter. So when Keaton and I are preparing for a workshop, we can take a stack of boxes and cut them up into squares. Something that with a paper cutter that would take, you know, a half an hour, you can do in 5 minutes with this. It is.
And they're like
It's a game
35
changing.
bucks.
Yeah, it's a game changing tool for working with lots of cardboard.
Yeah, because I tend to use the an old pair of kitchen scissors, but I can see that being a lot more efficient.
It's a lot more efficient and you don't get those awful cramps in your hand from doing
Mhm.
this over and over and over again.
You can see like do like a kind of a curve.
Uh-huh.
I don't know if there's an international cardboard creation contest for students every year called Make Do is the name of the company that makes tools for kids making things out of cardboard. And they've actually started, this is now the tool that they sell for kids to cut cardboard with.
Very
All
cool.
right. Well, you're welcome. And yeah, please feel free to interrupt with questions. Kaden and I love hearing other people's voices besides our own.
How much was the canary knife?
I think they're
They're
like,
about $10, I think, right? Because they were like, I
Yeah.
think they were $40 for 5. I think the last time we bought them.
yeah, let me check real quick.
Let me double check. They're
Yeah.
definitely a little bit more of an investment, but they sure are they sure are really, really, really cool. And they're durable too. Like I don't think the one thing I would recommend if you see this version, I don't recommend it. This is also a cutter that they make and it's retractable, which seems really cool, but the blade is not as steady. Like it kind of like even when you have it down here, it wiggles. When I'm using this one, and then I accidentally hit the retractor and it goes in. It's just, and it costs more. It's not my favorite. I don't think the benefits of having it retractable are worth it. Whereas this one is a little bit cheaper. It's stabler. It's sturdier. It's a workhorse.
And just have your kids wear gloves.
Yeah, wear gloves.
And
Like
like
they're
I
not.
said-
You can't stab yourself with it. Like handling it at any given time, you're really not going to hurt yourself. I mean, if a kid was holding it like this and another one like yanked it out of his hand, that could probably cut yourself a little bit. But yeah, just mainly it's that when you're going so fast and your finger slips, and that was how 2 people actually cut themselves last year. Was just because they were just having so much fun cutting cardboard and then their hand slipped and they cut themselves. But it's still like, it's like a paper cut style cut. It's definitely not a go to the ER cut. It's just put a Band-Aid on it cut.
Yeah. So just found them $3.70 for 5 or $9.30 for 1 on Amazon. I found it at Adafruit for $9.95.
Yeah.
So
And there might be, we've never pursued better wholesale costs. You can get a wholesale, they do have a wholesale division. So it's possible if you contacted them and were buying in some serious kind of bulk that you could get an even better deal.
I'm kind of I teach art, so I'm trying to think of different ways that I can, because the kids I teach junior high. It's a Title I school, and so kids are limited in resources, and so thinking of various different art projects. I've had to provide little containers of paint that they pick up at a location at the school and then that kind of thing. But that's kind of a somewhat inexpensive tool, but I don't
Right.
know. Has anyone experienced loaning out stuff like that or tools or during this COVID-19 experience that we have?
Experience lending them out.
Yeah, like like we loan out Chromebooks and things like that, so kids are
Right.
are 1-to-1, that kind of thing. I think we've got most of them back, but
I think the biggest thing
it's
is
still $10,
probably,
it
yeah, we certainly would have to budget for some attrition.
So Jess asked,
liability.
yeah, and that's the big question. I mean, we still don't know what budgets are going to look like for schools in the fall. Between tax revenues dropping off and goodness knows how many parents deciding that they're going to homeschool their kids rather than get them involved with school, it's difficult enough trying to figure out how we're going to find a way to fund connecting to every kid, since I don't know about the locations you guys are in. I think the odds in our region, even though in Washington State the virus is relatively under control, I still think we've got pretty high odds that a number of our districts are going to be online only by the time September comes around, if it's not better under control. So
Yeah, that is, we can be fully transparent that all of this we designed pre-pandemic. This was not designed to do remotely. So you guys are actually our first guinea pigs in terms of experimenting with how this goes to do remotely. And I can tell you as an instructor, the hardest part is I can't see what you're doing. I can't tell if you're having trouble. I can't tell if you're having success. I can't tell if you're participating at all, which I'm sure is something you've experienced with your own students. So it'll definitely take some thinking as to how well this would or wouldn't be adaptable to remote teaching, but it's interesting to try.
So Jess asked, how important is it to have 1/4" copper foil, or the ribbon is 5mm acceptable? And that's just a matter of personal taste.
Yeah.
As Caitlin showed when she was doing the 3-way connection necessary for the leaf switch there, actually having a narrower ribbon for that tile that she was working on would have been easier.
Yeah.
Than
You
the
can
fatter.
see this one that I made months ago, I was actually using a skinnier ribbon that I happen to have, and that's a little easier. I probably still for this tile would have had to cut it, but for this one, which is a different component that you guys don't have, I didn't have to cut it because it was just enough gap. Whereas if I was using this tape, I absolutely would have to cut it to fit that gap. So it kind of depends. It depends on what you're using it for, and it's certainly not a hardship to have to cut a little notch out of the tape. So.
Yeah, I probably should have, when I sent Dan the shopping list or put the links in the resources, probably should have spec'd the narrower tape, but I got the fatter tape for some reason.
It doesn't make all that much difference anyway.
It doesn't make all that much difference.
Yeah.
This gives you a little bigger surface to clip to.
And
Yeah,
there was some stuff that was available, some stuff that wasn't because of back orders, because of COVID. And so there's those issues, and then trying to figure out what all the components I need, and then make sure there's that cost of mailing it out. Luckily I had the boxes to go, put it inside of it. But again, there's that added cost. And then it's making sure that we did it all in time. And so unfortunately we had a lot of people that's like, oh, this would be great, I want to join in at the last minute, but I didn't have time to ship them the kits and everything else.
Yeah.
So, and I wish I would have shipped more alligator clips. That's something that in hindsight I should have done better on that. So
well, everything's working fine, and besides, when we do it next time, we'll have more time to prepare.
My guess is the advantage to the fatter tape is, like, young or old, there's a coordination issue. The thinner things get, the more practice and skill you need.
Yeah, you're more likely to have the thing where you accidentally tape the tape to itself and it gets all squished up. The fatter tape is definitely a little easier to work with dexterity wise.
Yeah, it's really going to depend on the complexity and the fineness of the pieces that you're dealing with. So if you've got a lead switch like Caitlin's there, where you've got leads that are very, very close together, the finer tape is better. If you're just doing legs on an LED that are spread out this way, the broader tape works fine. Actually gives you more surface area to work with, and it's easier for those tiny hands. So Caitlin, you want to just go ahead and jump right into just a plain old cardboard circuit?
Long tile, yeah. Get some of this stuff out of my way. So I think what we're going to do, I'm going to cannibalize, well, actually, I'll take a blue light, at least one of these components I won't have to cannibalize, but I'm gonna take my tilt switch off. I'm going to recreate the tile that my dad showed you earlier. That is a tilt LED tile. You can, if you get a button battery pack, you can put the whole thing on the tile, but I'm going to show just a different option. I'm just going to tape my power to the tile so that the tile will be free floating and the battery pack can stay on the desk. It'll still give us enough room. And I'm going to kind of pre-plan my circuit here. It can be really handy sometimes to draw what you intend to do, just so you can be thinking about, oh, I've already forgotten, not paying attention, which side's positive, there we go. So that you can just be kind of thinking about what your plan is and how much room you have on it, your tile, and et cetera, et cetera. So I'm gonna just work this off of here. Working it. So
Caitlin, is that the reason why you tape the copper tape on the bottom and then tape the copper tape over the top of it so you can reuse it for other tiles?
yeah, well, the reason I do the double with the copper tape is just because it creates a stronger connection. It would actually have been easier for me to remove it if I had only done one layer of tape.
Okay.
One layer of tape will usually work if you just have the tape. If the leads were sitting on the cardboard and the tape was on top of the lead, taping it down to the cardboard, because the adhesive is conductive, that usually works. I've just find that when you do the under over, where you have the copper tape under it and over it, that the connection is more consistent and it's stronger. And when I do that, I have less connectivity issues, because that's one of the biggest complaints with paper circuits, is that the connections are just so finicky. It can be difficult to, it adds a level of complexity to the learning process when you're trying to just learn how a circuit works, and you can't tell if you got the circuit wrong or right, or if it's just that you didn't squish the tape down hard enough. It can add a little bit of frustration level to it. Okay, where's my positive? Okay, so I'm going to pre-draw my circuit on here so I can keep track of which direction everything is going. So I've got my positive lead and my negative lead. So
Hey,
this is where I'm going to...
Can you hit the focus button on your camera?
Oh,
It's
yeah.
not out of focus.
Which one's the focus button?
Well, there's on the controls on the side there.
Yeah. There we go. There we go. That's better.
Much sharper. Thank you.
Okay. So I'm going to just write here where I plan to tape down my leads. I've got my positive's going to go here, and my negative's going to go here. And then we're going to go, the tape's going to go up and around the edges. And that's where my component's going to sit. And then around the side here. And my LED is going to sit here. And so I need to make sure that this side is positive and that this side is negative, so that the positive wraps around in the right direction. That's the biggest. When you're thinking about it wrapping around, sometimes it's a little counterintuitive which direction the positive should be on. Whoops. So I want to make sure that it's sitting this way with the long lead on the positive side. And this guy there. Now that I've drawn that, I can focus on getting one component at a time attached. Put this aside. And this is where my little gap's going to be, here and here for my components.
And if you want to get really esoteric, you can start teaching the kids the different schematic proper diagrams to stick in each of those places, make them feel really good and scientific.
So now I'm just going to overlap all of my drawings with copper tape, making sure to leave gaps where the components are going to be.
Some people at the corners just kind of fold and bend the tape so that without cutting it. One of the advantages of using the adhesive on the back copper tape is you don't have to do that.
Yeah, I'll show you that. That is, yeah, when you do the fold and bend, that can sometimes create a stronger connection because you're not actually disrupting the tape. So like go like this, and then a little twist. It does look a little chunkier. Just squish it down. And then there's my, where my LED is going to be. I should probably put this where I'm going to be able to see it after I put my tape down and keep track of what I'm doing. And then I make sure to leave my gap. Okay. Let's see that. This is where it's going to be. So I'm going to review while you guys are catching up. I'm going to put my components back where they're going to be so we can see the plan again. So the LED is going to go there with the positive lead on this side. My tilt switch is going to go up here. And, you know, and again, the tilt switch doesn't, there is no positive or negative. It doesn't matter which way that one goes. And then these guys are my positive and negative leads are going to go here. Plan.
And that's if you want to connect them up, you could just use the alligator clips if that's what you want to do.
Yeah. And maybe I will do that just to save myself a little bit of copper tape. Just go like this. The clips have pretty good reach, which is nice. Like that. And they can go anywhere on that strip. Be the plan. Unclip what I'm taping down. All right. I'm gonna go ahead and start attaching my components, just the same exact way that we did with the tiles. One of the nice things about the copper tape is you can just smush the crap out of it when it's all wrinkly and not looking so nice. And then it looks nicer when you smash it into it a little bit more.
And one of the things Kate and I didn't mention, but one of the, when you look at things like the wooden circuit tiles that people do, it's a great idea, but, and no, it's a great idea. I like the idea of doing something like this in a way that you can also make it aesthetically pleasing. You can actually care about what it looks like. And I know that's some kind of a weird thing, but form follows function. It's got to work first. But I think kids like making things look good. I know I do. And so that's one of the things I'm looking for with these materials is something that once we get it working, we can make it look aesthetically pleasing.
And this is also the tiles tend to be something that are made and then left as is, and as opposed to this steps straight up into making more stuff the same way, making different tiles. It's the tiles tend to be a cheaper version of little bits where you're making stuff and then you're taking it apart and you're putting it all away, as opposed to actually making your own little projects that are more, they're just something you can keep if you want to, if nothing else. Okay. Okay. Do I have the positive side? I think so. I can't see the little.
Yeah, the little flat side is hard to see on some of those.
Yeah, it's very just so, but I can eyeball the longer side.
Well,
We'll find out.
That's the advantage of using the copper tape first, is if you get it backwards, you can pull it off as opposed to soldering it.
Exactly.
I'm pretty liking Floyd's idea of putting a little black mark on the positive lead so you don't have to.
Yeah. Before you stretch it out. Yeah.
I'm stealing that idea, Floyd, forever.
That's okay. I also, just to save taking everything off, I scotch taped my 2 individual circuits to make one little board. I cut the boards down. And then
Oh,
that
yeah.
way, so then I just put one extra copper, let me see here, just connected with one of the copper strips right here, but these were 2 individual boards first.
Very cool. That's actually one of the things that, as we were brainstorming ideas on how to make these work, we kind of it's in our we're thinking about how to do it later, but using things like I've got a whole bunch of these little teeny tiny neodymium magnets that are really strong, and maybe somehow using those under copper tape on a piece of cardboard to help them hold together tighter. But that's a great idea.
Yeah, well, I liked your comments about exploratory learning. And I think even just so maybe you have a group of students and you say now you have these individual little circuits, how are you going to put them together and just see what they come up with?
Yeah.
And another thing I did with the little switch, I actually put 2 layers of the fabric tape, and that sort of gives it a little more surface area as you punch through. You'll have 2 layers of tape to rub against the little prongs, although it did work the other way also.
You get your bulb around backwards, maybe?
Yeah. What I could have done if I was thinking straight, I would have just done this first.
Yep, to test it.
Yeah, to make sure that I had it the right direction. Now I know for sure I've got the positive lead correct. Fortunately, it's pretty easy to pop it off and put it back on. The other question, there we go. So when I talk about finicky connections, you can see this is working better when I squeeze it.
Yeah.
Because these leads aren't having a super good time making a connection, so that's being a little finicky. Really, really smush it down, smash my cardboard. There we go. But again, even in its finickiness, it's teaching me a lesson about circuitry. It's teaching me about, you know, it's got to make a good connection so that that electricity can get through. And if we were to add a little bit of solder to these joints right here, that would solve everything. So it's kind of all of these things when we talk about the, you know, this is why copper tape isn't everybody's favorite, is because it is so finicky. That's what people like the least. But If your plan is to make something more permanent, then it's nice to mock up with the copper tape where you can just slap on some solder when you decide that you have it the way you want it and make it permanent.
Yeah, again, that's the beauty of introducing a little bit of soldering, is putting just a little tiny dab of solder on the legs of the components there, and you'd have a solid connection. Yeah. And you can do that on copper tape on cardboard a lot better than you can do it on copper tape on a piece of paper.
Yeah.
If you shake it too, the light should just sort of flicker, because that tilt sensor also works as kind of like a vibration sensor. Of course, with the 1 second per
You're probably
per second, we're not going to see that very well.
You're probably gonna have to try it on your own to really see how it works.
So shall we give them a couple minutes to work on their own?
Yeah, and feel free to switch up components at this point too. You don't have to just create this. You can you can add the leaf switch in there if you want to, and you can have a leaf switch and a tilt switch. There can be more than one switch in there.
Or you could put the buzzer on it and drive everybody in your house crazy. All right.
Oh, looks good.
One thing that we experimented with, and it turns out it's more complicated than you would think, is there are light driven sensors. They're light resistors. So depending on how much light they get, they either increase or reduce their resistance. And it turns out those take a little bit more of a complicated circuit. It's not just as simple as it's passing through voltage.
I'm gonna stop sharing just for a minute so we can see more people.
Yeah.
But if anybody has any questions or wants any demonstrations, I'll hop right back on the document camera.
And we were talking about the advantages of distance learning. One of the things or issues of distance learning, we've been doing remote presentations of various kinds for a while. And one of the things I've learned is whatever you think wait time should be in a live situation, in a remote situation, it's double that. Because, when you're in a live classroom, nobody has to remember that there's a mute button, and people don't start talking and then go, oh, wait, I have to turn my voice on.
Yeah.
Plus, it's one of the interesting things to me about the dynamic. People just simply take longer to respond in this kind of a situation.
Yeah.
So does this signal break down obviously over time on that copper wire? At what point do I start losing some of that voltage?
I don't think with the copper wire, there's very low resistance in it. It's no different than plain copper wire.
Okay.
There's a higher level of resistance in the conductive fabric, because it's actually fabric that's impregnated with metal particles. So it's not quite as, I'd have to go look at the specs, but it's got a little bit higher level of resistance in the copper tape. I think the copper tape, it's negligible.
Okay, great.
And it's also, relatively inexpensive. I mean, Dan, you just purchased the rolls to send out in the package. It doesn't cost that much. I love the whiteboard in your background. That's fantastic. Oh, we're not hearing you, Dan.
You're muted. Speaking of,
yeah, sorry. We actually paint all of our walls in our classrooms with this stuff, so it's all over.
Great.
nice. We're actually pretty surprisingly on schedule.
I know that's really odd.
It's very, very out of character. Yeah.
Maybe online learning is more efficient.
Oh yeah, I see the LED and the buzzer in parallel. Awesome.
I love it. See, I picture having something on my desk that says, "Don't turn this over." Of course.
Love that. I'm gonna do that.
And that's, that's getting into, we didn't talk about the difference between being in sequence or being in parallel, but we'll plug that as something that you can get deeper into. I don't know. I really enjoy, by the way, if you want to get deeper into, I think it's SciShow has a really great electricity series on YouTube, which I found to be a really good way to really understand the deeper concepts if you want to go deeper. It looks like it's flickering. I see it.
I love it.
Thank you. We
For
really
whatever
appreciate
with that,
the visual feedback.
yeah, for whatever reason with that one, it's like solid, and then if I shift a little bit, so someplace there's like a weak link part of it, and I think
It
it's
could
in my
be the ball bearing, but
yeah, I think it is, because when I cut that out of the whole process, it stays solid. So
yeah.
my
Yeah,
switch is a little funny.
so
That's where it works as a motion sensor, though.
yeah,
So
like
I
this
got a
one-
good motion sensor then.
Yeah.
yeah, this one here flickers just from my hand. When I set it down, it stops. So it's very, very sensitive, depending
Yeah,
on
so
how much of an angle it's at.
that might be what I'm experiencing then.
Yeah.
But as Caitlin said, even with all the tape you put on these legs, that it can still be iffy. And if the circuit starts to warm up, resistance causes heat.
Right.
Heat causes more resistance, and you get a negative loop going. So that's why getting just a little tiny dab of solder at these legs will make these much, much, much more robust, not only in holding things together, but in making a good solid connection.
Mm-hmm.
And
Also,
go ahead.
no, you finished your sentence first.
So, and like if you do tape at the corners, like a piece of tape, with a piece of tape, you can put a little dab of solder at the edge of where those two pieces of tape overlap to make sure you get a good connection there too.
I was just going to say that's why one of my first troubleshooting things when I'm having connectivity issues is just to squeeze these points really tight, just to go in and squish them even more with my fingernails and squeeze them and see if actually squeezing them makes the circuit come on. That'll immediately tell me that that's where the weak point is just in the connections here.
Good idea.
So what I'm going to do now is I'm going to turn on screen sharing, and I'm going to walk through the list of resources that Kate and I have put in the Moodle that go with this. So let me pop this open.
Oh, and we have our components cost slide too.
Actually, yeah, let me jump to that first. So when we talked about things being inexpensive, this is the cost of the various components that we've been using here today. The motor and the battery pack together, when you buy them from the link we've got, that's $1.50. The leaf switch is 31 cents. The little vibrating motors are $1.27. The awful noisy speaker is 45 cents. The tilt switch is 40 cents, and the LEDs are 7 cents. By the way, the clear one, there's two clear ones in your pack. One of those clear ones is a flashing LED. It cycles through colors. So again, when we talk about easily amused, I absolutely adore the blinking LEDs, and I make sure they're part of every activity set that I do because they're just simply so much fun. So now let me switch to
And how much are the alligator clip sets?
the alligator clip sets. I'll have to pull that up on. I've got to stop screen sharing and then screen share to the right one. Let's pull that up. So a set of 12 of those is $4 for 12. So they are really inexpensive. So what we put in the Mountain Moodle, so here's that one link that I think it was Floyd that just shared with it, build a simple circuit from a pizza box. If you want to see the circuit tiles original instructable that sort of spawned this whole idea of do-it-yourself circuit tiles like we are modeling off of, that's this link here. Microsoft has actually put together a cardboard circuits resource page where they have instructions on how to make some of the kinds of circuits that we've done. It's a work in progress, and being electrical engineers, they don't care about how nice things look. Honest to goodness, they are some of the ugliest circuits I've ever seen in my life, but by golly, they work. So you can work on making them more aesthetically pleasing. There's a wonderful company called Chibitronics, and they've done a lot to get the paper circuits thing going. They sell their own products, but they have lots of cool project ideas for things that you can do with LEDs and copper tape and batteries. And you just don't have to do paper. And so it's a really great place to go look for ideas for the kinds of things that your kids can be doing. Let's see. So they've also got lesson plans and templates specifically for teachers. So you can find lots of great resources here. This is the link for the Zip Snips tool that Caitlin and I talked about. And my note on it is just buy one seriously. You just need to have one of those. You can get the copper foil tape and the conductive ribbon at Adafruit. Now those links are here, and you can get them in various sizes. You can also get them at SparkFun. I'm not trying to play favorites, but like the conductive nylon fabric tape, if you buy it at SparkFun, it's an Adafruit product, so you're still buying it from the same original company. There's the link for the Canary Cutter tool, also at Adafruit. These are the link that we use to buy those leaf switches in bulk, the batteries and holders in bulk. These are the potentiometers, and I'll come back and talk to about those in a second. Color LEDs, the flicker LEDs, and they come in fast flicker and slow flicker. And I'm also a big fan, again, I'm easily amused by blinky things. You can buy inexpensive candle flicker LEDs in bulk. And so if you kids want to create a project where it looks like it's a fire or a candle, you can get those kinds of LEDs. The reed switches are magnetic switches, so that you can put those in a circuit that when it's exposed to a magnet, it turns the circuit on. You can get them of two flavors. You can get them where the magnet closes the circuit, and get them where the magnet opens the circuit. Most of them, the magnet closes the circuit or turns it on. And the ones that I have linked to there are plastic cases. Many of the reed switches that you find online have little glass cases, so they're pretty fragile. We linked these plastic ones because they're a little bit more robust. If they get exposed to a magnet for too long, especially a strong magnet, they can actually get stuck. So that's one thing to keep in mind. But those are the same switches if you've seen home alarm systems where there's a little plastic doodad on the door or a little plastic doodad on the window. That's a reed switch in there. There's a magnet on one side and there's a reed switch on the other. So when you open and close the window or open and close the door, it's opening and closing that little magnetic switch. But it's also cool for having things where you can actually have the reed switch underneath the cardboard and put the magnet on the other side. So it looks like magic when you make the lights go on and off. There's conductive epoxy. So it's expensive. It's, I think it's like $30 a tube. So you don't want to use it a lot, but It's expensive because the metal in it is actually silver, but it's very robust. So if you want to make things that, if you don't want to solder, absolutely don't want to solder, and you want to glue things in a way that's really robust, conductive epoxy works really well. Conductive glue is much less expensive, but it's not as strong as epoxy. It's kind of, it has to dry overnight, and it's kind of brittle. So it's not something that will handle a lot of abuse well. The piezo speakers in bulk are here. The vibrating motors are here. These are these little button battery holders. I'll show you one in a second with the regular camera. If instead of using the 9-volt battery packs, you can get these little battery holders for the round button batteries, the 20, 32, 3-volt batteries. And it has 2 little legs in the bottom, so it'll punch right into the tape like the components do. So it's much easier to incorporate right into a project, and they cost, so those are 68 cents a piece. And when you, let's see, does this one show the picture of the bottom? Yeah, so it's got these little legs in the bottom, so you can punch those right down into the tape. You do have to then glue them down or something so that they keep their connection, but it's a nice way to be able to incorporate your battery right into your circuit. Those are the slow flicker LEDs. If you want to DC the motors without the battery packs, that's where you can get them. And this is where you get the little tilt ball shaking switch. So that's the quick run through of the resources. And oh, the one last thing to do. Let me get this pulled up right. If you want to get hold of Caitlin or me, this is our contact information. Our website is mcquinnable.com. My Twitter handle is conmick and Caitlin's is ccmac. I'm not a voluminous tweeter, but I do send stuff out occasionally. And if you want to contact either one of us with any questions, we love questions because that means that you're actually trying something we talked about. I'm Con at mcquinnable.com, and Caitlin is Caitlin at mcquinnable.com.
We especially love feedback about someday when you can do this in a classroom. We would really love feedback about how it went, like what was unexpected, what was different, what was a challenge, what was something new that you figured out on your own that maybe we could incorporate in for teachers in the future.
Yeah, we are shameless about stealing things from people who discover things, but we always try to give credit where credit is due.
Yes, if you send us a picture, we will ask permission before including it in future presentations.
So with that, what other questions might you have of us? You can either pop it in the chat window. Michael's beard just grew about 9 inches during this session. One side of the cardboard circuits. Yep, I'm really sorry. It's I love it.
So I just took the 2 blinky ones because I got 2 white ones. One's a slow blink and a fast blink in my package, and I just slipped them underneath so that they're in parallel. And
yeah.
So it's interesting is certain combinations there's not enough voltage to light the blue one, so it turns blinky. It turns blinky, but it's highly variable because it'll stay on for quite a while till the cycle's right, and then it gets into, and now it's off for a while. But
yeah, so here's an interesting thing. You'll see if you take the blinky light and you put it on one of the little buttons, you can just take it and put it on the button cell, and it'll cycle through all the colors. But as the battery starts to weaken, colors will start to drop out. Gotcha. So it's kind of a fun little long-term science experiment to see which colors take more voltage than others, because at the end it'll just be blinking one color forlornly before it finally expires.
So I will give the feedback in the moot area where I'm supposed to, but I will say I really enjoyed your presentation. I think, you know, like if this is the first time that you've done this online, you've done a great job. And
Thank
I
you.
really enjoyed the you guys were very organized at the you stayed organized the whole time, but being organized and kind of showing us at the beginning what you were doing and everything, I thought that got us off to a really good start.
Great, thank you.
Yeah, I really enjoyed the presentation. Thanks, you guys. It's pretty fun. I just finally discovered my Blinky.
Yeah, yeah, that's the one thing we got out of order. We should have done, always usually do the blinky early on, but you know what? We
Yeah.
saved the best for last.
Right, yeah.
But see, it's more exciting when you discover it yourself.
Yeah.
Yeah, that is usually the plan.
So
Okay,
it just
cool.
mentioned, yeah, that you can tape you can take the button cell and an LED, tape them together with a magnet, and you can throw them on metal things. So she learned that at the Franklin Institute. Yeah, that's a great place.
So I do some teaching for a local homeschool co-op here, and I've done other electronics projects, but I didn't know about the cardboard circuits. And I've been mainly working with like 6th, 7th, 8th grade kids. But now I've just got a whole bunch of ideas for even younger kids in that co-op. I mean, this can really be used, I would think, with kids even in like 1st, 2nd grade.
Yeah,
So thanks. This has just been awesome.
Thank you.
great.
Thank you so much.
Have you guys tried experimenting with I know it's probably a little bit more expensive component, but with a RGB LED?
We haven't done that. Actually, that was a wonderful segue. You'll get your payment afterwards. There was one more thing I wanted to show, and if you start, as you get into more sophisticated things, so this is using a BBC microbit, and so
Which
I'm
is a
using the microbit.
microprocessor.
What's that?
I said, which is a microprocessor, if you're not
Which
familiar
is a
with it.
microprocessor. So this has been programmed now. So I can control these 3 LEDs. I wrote the program using what's called make code, which is the usual way that people program these cute little microbits. So I programmed it to count 1, 2, 3, 1, 2, 3, and as it counts 1, 2, 3, it lights the green. 1, 2, 3, 1. Actually, I seem to be off one here. 3, 2,
Yeah.
3. All right, little coding error there, but we will. So you can get much more sophisticated with this by using other things like microbits, or Adafruit sells a wonderful device called the Circuit Playground. Some people are using Arduino. So once you understand the basics of how to use the copper tape to create the circuits on the cardboard, then you can start incorporating other more sophisticated items.
And that's just using block-based coding too to do that. If you're not familiar with what you can do with something like a microbit, it's pretty accessible in terms of, you know, the learning level. You don't have to write code from scratch to recreate that project.
And they're inexpensive. The
Very.
that only costs the microbit, I think, costs $15, something like that.
Yeah, 15 is the cheapest I've seen.
And this is, here's the code that's driving the microbit right now. So it's running forever, and it displays number 1. Digital write pin 0 to 1 means turn it on. Pause for 1 second, turn it off, show number 2. For the next pin, turn it on, wait for a second. So it's real simple coding. It's very accessible to kids, and then very easy to then transfer back into, or transfer into your microbit. And there's options there.
In my someday pinball project, for instance, I could use the microbit to keep track of my score.
And the microbits, they actually have built-in like button sensors. They've got built-in tilt sensors. They have built-in Bluetooth radio, so they can actually send messages from one microbit to the other. So when you want to go to the next level, they're very, very sophisticated and very, very inexpensive, and there are tons and tons of resources for them online. Microsoft is a big supporter of the microbit.
So if they've got Bluetooth or Wi-Fi, I forget what you said, then you could do your synchronized pinball.
Yes, they do have Bluetooth, and yes, you could. So
So you could build two of your pinball games or whatever, and then they could be synchronized.
Yeah.
now we're getting really sophisticated.
We can all dream.
All right,
Yeah.
so here's our next workshop, building a pinball machine.
Yeah. that might be a multi-day workshop, but it would be fun.
All right, any other questions or that anybody has? If not, then
I just want to say thanks so much. Again, I just saw these guys in Seattle, and I'm like, okay, this was amazing. We've got to share this. So thanks so much for coming over to the Moot and experimenting in this online environment with us and
Yeah.
part of our conference. I really appreciate that. So,
well, thanks for inviting us.
Yeah. It's a lot of fun.
okay.
Thank you, Con and Caitlin.
All right.
Thank
Take care.
you.
Okay.
Thank you.
Bye.
Bye.
All right, bye-bye.
Hey, Con.
Yeah,
Do you guys want to talk? I can just,
sure. I think Caitlin already popped off. I can get her to pop back on.
I thought I was going to talk to you, Con. You're fine. No problem.
Okay.
No, we're good. I thought that guy was going to stay on, but he was jumping
Oh,
on.
okay.
Perfect. Yeah. Thank you. You're welcome to participate in any of the rest of the stuff that goes on. I don't know if anything
Yeah.
of interest to you or not. There's a couple of great keynotes coming up, and yeah, we kind of gamified it. I don't know if you saw the Moot coin and things that are happening in Moodle.
Yeah.
And we send out in person. It's a lot of fun because we have every night we have an event, and everything is covered: your food, your beer, your wine, and we allow people to stay on campus in the dorms. So it's like, $30 a night to stay, and then we just cover everything for the whole. We pick you up from the airport, bring you to campus, and then it's just a
Wow.
thing. So maybe next year, if we're done with all these things, if you want to come out to Montana, obviously you have friends in Deer Lodge, right?
Yeah. Yeah. Actually in Avon, but Deer Lodge is the biggest nearby town.
Oh yeah, well, we're not very far from Avon. I mean, it's about half and half, and
Yeah.
yeah, you can drive right over to Avon. It's right across the thing here. So
Cool.
nice. So
Well,
I don't
that
know.
sounds like a lot of fun.
Think about it.
Yeah. No, well, my wife and I actually have been planning, we were going to take a trip to Montana this summer to stop and visit the Graveleys, but also she's wanted for a long time. Her grandfather worked for one of the railroads, and she has all these old photographs from like 1913, 1914 of when he and a survey team were going through, I think it's Wind River Canyon, planning where the railroad was going to go. She's always wanted to come over and go there and see the route that he traveled, that she has all those photographs for. So that was going to be this summer before the pandemic. So maybe next summer.
Yeah, no, definitely. If you could incorporate it on, because that's what a lot of our folks do. They come from all over, and they usually, do the conference here, and then they'll go to Glacier, they'll go to Yellowstone, or they'll just go camping or whatever it is. So
Yeah.
perfect. Well, thank you again so much. I really appreciate this. A lot of
Well,
fun.
thanks for sitting in on our session with us. It was great to have you here.
I'm learning every time, so I'm good.
Great.
Okay, Con.
All right. Thanks, Dan.
All right, thanks. Bye-bye.
Bye-bye.